So I recorded the whole end of this lesson, the whole second part, and then it deleted before I could get it uploaded. So I've already wrote the notes in, but we're still going to go over them. That way you can see them. Linear function word problems. We have slope-intercept form, which is what you're used to. This is what you did in 8th grade that you liked. The y is the range or the output. The m is the slope or the rate. The x is the input, so how many, how much of the domain. And the b is the constant. If the total cost is something that you do not know, then it will be represented by the y value. So, let's look at this example. Cameron is designing a calendar as a fundraising project for math class. The cost of printing is $500 plus $250 per calendar. The word per right here tells me that that is the rate. Okay? Write an equation that models the total cost of printing the calendars. So if we just look at this, the total cost is going to be $500, right? Because that's the cost of the printing, plus $250 for every calendar that we order. So y is our output, our total cost. Our slope is our rate, cost per calendar. X is the number of calendars. And B is our constant, the $500 that it takes. Okay? So our equation would be y equals 250, our rate, times the number of calendars, we don't know what that is yet, plus the 500. In order to become a member at a yoga studio, there is a $100 annual fee and a $5 fee for each class that you attend. We want an equation that models the cost for being a member at the yoga studio for a year. So we're only going to have one of these annual fees with X number of classes. Well, there they tell us the X, the number of classes. How much does each class cost? What is the rate of the class? $5, right? What is our constant? What are you getting charged no matter how many classes you attend? The $100 annual fee. And when you solve it, it will be your cost for attending for the year. Notice I'm trying to cover up these answers because I've went through this once. Okay. An airplane is 30,000 feet above the ground. It begins descending, descending, at a rate of 2,000 feet per minute. Descending 2,000 feet per minute. Write an equation to model the situation. Find the altitude of the plane after 5 minutes. So, we started at 3,000 and we're going to subtract 2,000 feet per minute. You could write it in either one of these forms. This is with this on the back end, this with it on the front end. So if I want to know, I want you to now solve and tell me what the answer is for 5 minutes. You can pause the video. For 5 minutes, you should have got an answer if you are now at 20,000 feet. So when you want to find the y-intercept from an equation, the y-intercept is a point or an ordered pair that looks like 0, comma, and a number. So the x value of the y-intercept is always going to be 0. The y-axis is represented by the equation x equals 0. To find the y-intercept, set the x equal to 0 and solve for the y. Your answer is always going to be an ordered pair. These I can't help. The answers are just here. So here, we know because of the way this is set up that 1 is our y-intercept. But if we wanted to make sure, we just plug in 0, 3 times 0 plus 1, and we get y equals 1. There's our answer, our ordered pair. In this form, standard form, it's a little more difficult to spot. So we plug in 0 for x, and we solve for y. So 4 times 0 is 0, plus 2y equals 8. So 2y equals 8, we divide by 2, and we get y equals 4. Our y-intercept is 0, 4. The x-intercept is the opposite of that. You have a number in the x value and a 0 for your y value. The x-axis is represented by the equation y equals 0. To find the x-intercept, you're going to set the y equal to 0 and solve for the x value. So this just flips it. And the answer is still going to be an ordered pair. Let me see if I can hide the word, at least. The answers are going to be there. So, here we set the y to 0. And we solve for x. So we subtract 1, divide by 3, negative 1/3 equals x. Okay? That's where we got the 1/3. Here you're going to do the same thing. This is standard form. So our y is 0. Divide by 4, x is equal to 2. So you take this and you plug it in there. Okay? So when you graph them, you can also graph with inputs and outputs if you want, but this way is preferred by students. So we could use it when graphing by inputs and outputs. That's our table. We could do that, but most of you know that this is your y-intercept, this is your rise over run, and how you're going to count it. Sometimes it's easier to write or understand an equation from a word problem. This is used when the missing values are not the total amount. It's difficult to graph from this standard form. Ax plus by equals c is your standard form. So you have to convert it to slope-intercept form. Slope-intercept form is y equals mx plus b. So we're doing the same thing. We're just isolating the y. We're getting the y all by itself. Convert from standard form to slope-intercept form. So here you subtract the 4x, bring down the negative 2y equals negative 4x plus 8, divide by negative 2, y is equal to negative 4x plus 8 over 2. Well, this is the same thing as this. I just wrote it a different way. So our final is y equals 2x minus 4. Here's some others for you to try. Make sure you can work them and get the answer. And that's linear word problems.